Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's easy level puzzle. And as always, take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Peach Rectangularity by Nicholas Duhale, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Every set of 3 adjacent digits along a peach entropic line contains 1 low digit, 1 middle digit, and 1 high digit. The low digits being 1, 2, and 3, the middle digits being 4, 5, and 6, the high digits being 7, 8, or 9. So, for example, we could have, say, a 3 here, a 9 here, and a 4 here, and that would satisfy this because these 3 digits must have 1 low digit, which we do, we have a 3, 1 middle digit, which is the 4, and 1 high digit, which is the 9. So that's an example of how this entropic line could work. And we have, within a cage, digits must not repeat, and they sum to the small number in the top left corner. So, for example, if this were, say, a 6 here, this would have to be a 4, because these 2 digits must add up to 10, because they are both in a cage with a 10 in the upper left-hand corner. And they're the only digits in that cage for that reason. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. So, for any type of entropic line, or basically any line where you have to have one of each set for any 3 consecutive digits along it, or 3 adjacent digits along it, every third digit is going to be this, or every third cell is going to have to be the same set. And the reason why is obvious, because if you basically take a look at these 3 digits, they must all have 1 digit from each of the sets, right? So this is one set, this is a different set, and that's a different set than the other 2. Well, what about the next 3 cells that we have that are adjacent? That would be these 3. Or you could go this way, either way. But going from this set to this set, we have these 2 sets are the same, because they're in fact the same digit, but you're losing a set, and the set you're losing is this one, which would mean that this has to be the same set as this one. Well, so and it's the same thing this way, right? If you change from this to this, these 2 cells are the same digit, and so they're the same sets. But this one we're losing for this set of 3 cells, which means that must be the same set as that. So, for all these rectangles, the middle 2 digits, they are 6-cell rectangles, which means the middle 2 digits must be of the same set, no matter what. And to add up to 10 as the same set, you could have to have 2 middle digits, and they must specifically be a 4-6 pair. To add up to 15, they have to both be 2 high digits, because you either have 6, 9, or 7, 8 adding up to 15, and 6 and 9 are not the same set. So this would then have to be a 7, 8 pair as the high digits. Same with 2 digits adding up to 5. You have to have 2 low digits here adding up to 5, because it's either 1, 4 or 2, 3 adding up to 5, and the 1 and 4 are different sets. So this must be a 2, 3 pair. With 9, it's the same thing as the 10, because any other pair, 1, 8 are different sets, 2, 7 are different sets, 3, 6 are different sets. Therefore, this has to be a 4, 5 pair here. So this is a 4, 5 pair. Which means, in column 4, we have these 3 are the same, must be different sets. So we're guaranteed one of these is going to be a 6. That means we have 2 middle digits in column 4, and a third one accounted for by these 3 digits in column 4, which means the remaining digits in that column cannot be medium. Therefore, they must be low or high. Well, then for this entropic line, for this set of 3 digits, where is the middle digit? It must be here. And so this must be middle. This must be a high and low pair. We have the same thing here. This has to be a blue-red pair, which makes these green, which makes this a blue-red pair. We have 2 blues here. We have 1 guaranteed blue here, which means this can't be blue. This is a green-red pair. And this must be a green-red pair. That leaves these as blue, and this is green-red. Same with this. No reds here because we are guaranteed 1 red here. And both of these are red, so these cannot be red. This is blue and green, which means this can't be blue or green. It's red, which means this has to be a blue-green pair there. Okay. Okay, so these are both red. That one of these is going to be red. This is a blue-green pair, blue-green pair, blue-red pair, blue-red pair. This is red-green as a pair and red-green as a pair. Remaining digits here, these are both green. This is a blue-red pair and blue-red pair. And also this must be a blue-red pair here, because we have 3 greens guaranteed in column 3 already. So these can't be green. Same with this. We have 3 reds already, so this is blue-green as a pair. And we know there's 1 of each here. There's 1 of each here. So this must be a blue-green pair, 1 of each. We have 2 guaranteed greens in this box, which eliminates green in the rest of the box. So this can't be green, it's blue. That means this can't be blue, it's green. This can't be blue because we have blue and red already here. So that's green. That eliminates green there, so it's blue. This is blue and red as a pair. This has to be blue and red as a pair. So this has the same thing. This has green and red as a pair. Again, 1 green is guaranteed here, so this can't be green. It's red, which means this can't be red. That's green. It means this can't be green. It's red. That can't be red. It's green. So this is blue and red as a pair. Remaining digits in this box 7. We only have 1 blue here. We have to have 2 more blues here. Okay. Same with box 9. We have only 1 guaranteed green here. The rest must be green. Box 3, similar situation. We have 1 red here. The rest must be red. And same with box 1. We have 1 green here. There's no other green in the rest of the box, so we have 2 greens guaranteed here. Row 4, we have already all the reds guaranteed, so this is blue-green as a pair. We have 1 green here. Okay, so we have 6 cells which have to be blue and red in box 5. That eliminates blue and red in the rest of the box, so this can't be blue or red, it's green. We have a guaranteed green here. Sorry, we have a guaranteed blue here and 2 more blues here. That eliminates blue in the rest of the column. We can't have 3 greens in the rest of row 5. So this can't be blue, it can't be green, it has to be red. We have 2 greens here. Well, we don't have any information there. We should, actually. This is guaranteed to be 1 red here, 2 reds there. This can't be red, it's blue, which makes this not blue. This is also not blue, it's red, which makes this not red, it's blue. That's 3 blues in box 5, so this can't be blue, it's red. We have 1 blue here, that means this can't be blue, it's red, which means these can't be red, they're blue. Okay. This has to be 6. That's the only remaining middle digit in column 4. So since this is 6, this can't be 6, it's 4, which makes this 6 to add up to 10. Which means one of these is a 5. Remaining digits of row 1. Actually, we don't have that much information. Remaining digits of column 9. We have 3 reds guaranteed already in the column. We have 3 greens already guaranteed in the row, so this has to be blue. So we have 1 blue here, 1 blue here, and 1 guaranteed blue amongst these two, because one of these is blue, and that's a blue, but that's only 2 blues in row 4. So all the blues are accounted for in box 6. We also have 1 green here, 1 green here, and a green here, so this can't be green, which leaves that as red. That leaves this as blue. We have 1 red, 1 blue here. 1 blue here. Don't have as much information about column 5, though. That's interesting. We do know this has to be, one of these has to be a 5. This must be a 4-6 pair then, which makes this a 5. So this cannot be 5 anymore here. It would only be 4 or 5 anyways. And this can't be 5 because of 6 in the box. So 5 eliminates 5 there. So it's 4, which makes this 5, which makes that 4. This is 4, 6, and 5 there. That leaves this as a 6. This can't be 5 or 6. It has to be a 4. That means one of these is a 6. That leaves the middle digit here as a 4, and the middle digit here as a 5. Okay, that means this can't be 7 or 8 as a high digit. It's 9. This can't be 2 or 3 as a low digit, so that's 1. That leaves this as 7 or 8, and we have a 7 or 8 there. So 9 has to be one of those two with the 7 or 8. This is 1, 2, and 3 as possibilities. This has to be 7 or 8 here. Each of these sets of digits are sets of 3 digits, 1 low, 1 middle, and 1 high. The low so the lowest you can have is 1, 4, and 7, adding up to 12. The highest you can have is 3, 6, and 9, adding up to 18. But this doesn't tell us enough information there. We know this middle has to be 4 or 6. Can it ever be 6? 1 and 7? Yeah, that could work. 13 as a minimum. You cannot ever have 9 here. If this were 9, 9 would have to be with 1 and 3 specifically, but those are both lows, and we know this is always 1 low, 1 middle, and 1 high. So no 9. 8 works with 1 and 4. 7 works with either 1, 5, or 2 and 4. So this cannot be 9 here. Where is the 9 in box 1? It must be there. One of these two is a 9. This being a high, and this also being a high. Again, so what could the possibilities here be? 1, 4, 8. Or 1, 5, or 2, 4, 7. This can't be 5 because of 5 in the box. Okay. This has to be 2 or 3 here. This is 2 or 3. 7 or 8. Can this ever be 9? This can't be 9, but we could have the 9 as one of these two. Again, this can't be 9, or it could be 9. 9, 4, and 1 is fine. Oof. Okay, never mind. One of these two digits is a 6. One of these two digits is a 5. These are low digits. Can you ever have 1 with a medium and high digit adding up to 17? The answer is no. So this is 2 or 3 here. 2 would have to be with 6 and 9. And 3 could be with 5 and 9. So we could have 6 and 9. No 6 here. Or we could have 5, 9, or 7, or 6, 8. With the 3. These middle digits are 4 and 5 here. Can you ever have 4 add up with a low and a high digit to add up to 17? No. The answer is no, because 3, 4, and 9 added up to 16 at most. So this must be 5 here, which makes this 4, which means this combination of digits is 3 and 9 as a pair. 4 eliminates 4 here, so this is 5, 6 as a pair. This can't be 5 anymore. So we can no longer have a 5 here at all. So as a low digit with a medium digit, it has to be either 1, 4, 8 or 2, 4, 7. So we're guaranteed one of these is a 4. That eliminates 4 in the rest of the column, so this can't be 4. Where is the 4 in row 6 then? It has to be here. So this can't be high, this can't be low. That's high there. One of these is high, so this can't be high here. So because we have 3 highs in column 2. That means this can't be medium, it's high, which means 4 has to be here and 5 has to be here. 4 eliminates 4 here. Where is the 4 in box 1? Cannot be here anymore. So it has to be here, which makes that a 4. So this is medium. This can't be medium. That's low. This can't be low. So this can't be a 6. Where is the 6 in row 4? It has to be here. That eliminates 6 here, so it's 5 and 6. Okay. 13 minus 4 is 9, 1, 9, and 2, 8 both satisfy that. This is 3, 5, and 9. We can't have 3 here. This is a high digit. It cannot be 9 because of the 3, 9 pair in the row. So that's 7 or 8. So then 9 has to be one of these two digits here. That leaves this as 7 or 8, which means the only high digit remaining in row 7 is a 9, because we have a 7, 8 pair already in that row. So this is a 9. That eliminates 9 here. So this 7 or 8. This 9 eliminates 9 from being here. So it could still be 2, 6, and 9 there. 6 cannot be here anymore. Where is the 6 in box 2? These are not medium because of the 3 mediums in the columns. This can't be 6 because of 6 in the row, so 6 has to be there. That's green. That's a 6. We don't know what this is. It's blue or red. These are 1, 2, or 3 remaining. That's not too helpful. Remaining digits of row 2. We have 1, 2, 7, and 8. Obviously, this is 1 or 2. Don't have that much information here. These are 7, 8, or 9. The lows are 1, 2, or 3. So we're guaranteed one of these has to be a 3 here. So this has to be 1, 2, or 9 here. Because we have a 3 guaranteed in column 1 in one of these two cells. So these can't be 3. Well, where's a 3 in column 2 then? Can't be here, can't be here, so it must be here. 3 makes this not 3, so that's 2, which makes that 3 there. 2 eliminates 2 there, so it's 1. So it's 1, 4, and 8, adding up to 13. That's 8. This has to be 9, which makes that a 7. That 7 eliminates 7 there, so it's 8. No 8 furthermore here. No 7 there. These are 1, 2, and 3. No 1 here because of 1 in the row. No 3 here. 3 eliminates 3 here. So this must be 2, which makes that a 1. 3 eliminates 3 here, so it's 2. One of these is a 3 left. 2 eliminates 2 here. 2 also eliminates 2 there. Where is 2 in row 7 then? Cannot be here or here because of 2's in the column. So 2 has to be here. It's 2, 6, and 9 to add up to 17 with a low, medium, and high digit. So this must be 6 because it can't be 9 because of 9 in the box. So this is medium. This can't be medium. That's high. No high here. That's medium. No medium there. It's high. That makes that 6 and 9, which eliminates 9 there. So it's 8, which eliminates 8 there. So it's 7. That makes that a 9. 7 eliminates 7 here. It's 8. 9 eliminates 9 there. So it's 7. So 9 eliminates 9 here. It must be a 3, which is low. That eliminates low there, so it's high. No high there because it's low, because these are high. No low there. Okay. 3 eliminates 3 here, so it's 2. No more 2 available here. Where's a 2 in box 1? It can only be here. So that's 2. That eliminates 2 here. It's 1, 3 as a pair. 6 eliminates 6 here. So that's 4. That means the remaining 2 digits must add up to 10, which is 14 minus 4. 8 eliminates 8 here, so it's 7, which makes this 8. That eliminates 8 as a possibility here. 3 eliminates 3 there, so it's 9. These two add up to 10. So it's 1 and 9, or 2 and 8 here as possibilities. Remaining digits in column 7 are 3 and 7 left. That leaves this as an 8. This becomes a 4, 5 pair here. 4 eliminates 4 here, so it's 6. Remaining low digit in column 8 is a 1. It can't be here, so this cannot be low. It's medium. This can't be medium. It's low there. That 3 mediums in column 8 eliminates medium there, so that's low, which means this can't be low. That's medium. And must be a 6. That leaves that as a 1. We only have 3 and 4 left in row 4, so this can't be 3 because of 3 in the column, so it's 4, which makes that 3. 3 eliminates 3 here, so it's 1, which makes this 3. No more 2 available here. 1 eliminates 1 here, so that's a 3. No more 3 in column 3. Where is the 3 in column 6? Cannot be here because of 3 in the box. These are filled out, so 3 has to be here. That leaves a 2, 8 remainder in column 6. This can't be 8 because of 8 in the row. So this is not high, it's low. This can't be low, it's high. And leaving that as a 2. That eliminates 2 there, so it's 8. It cannot be a 2, 8 pair then. It must be 1 and 9. So this is the high, this is the low, that eliminates the low there, and high here. So this is 2, this can't be 8 or 9, so that's 7. 1 eliminates 1 here, so it's 3 and 1. That means no more lows in row 8, so no low there, it's high. That means this is medium left. High there, low there, eliminates low here. Because we have 1 and 3 are accounted for. That leaves 7, eliminates 7 here, so it's 8, which leaves a 2 remaining in column 4 and is low. So this can't be low here. It's high. No, it's too high. These are all lows. Interesting. So low, low, which means this cannot be low here. It's high. This can't be high here. It's low. So that leaves this as 2. We have 1, that's 7. That leaves this as a 1. 8 eliminates 8 there, so it's 7. We have a 5 there, which means this can't be 5. It's 4 and 5. We have an 8 remaining. That means this has to be, this can't be high. It's low, which makes that a high there. So it's 3 eliminates 3 here, so that's 7, which makes that 3. Remaining digit in row 1 is a 9. This is a 5, and that must be 9, and this must be 7. So that's a solution. Yeah, pretty straightforward in how these interacted. I've done actually a decent amount now of Nick Duhale's rectangularity puzzles, and they've always been very interesting. Yeah, this one's different than I don't think I've done. Have I done a? I think I've done a modular one too. This felt slightly different. This has felt slightly different than the other ones, I feel. Feels more straightforward, I guess, but maybe because I've already done all the other rectangularity puzzles, I sort of know how the break-in is. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.